So I'm just going to tell you a little bit more about a project that we were working on in the middle of the pandemic. It was pretty clear that protecting staff from aerosol particles was going to be a big problem. You'll hear a lot more about that from Professor Tim Cook, one of our keynote speakers in the symposium itself. But we wanted better PPE, and we were working with a number of companies on a number of research projects that all got shelved in the middle of the pandemic. And they said to us, is there anything we could do to help? And we said, we need better PPE. So they went away and came up with Bubble Papa. And here's a little bit of explanation about what it actually is. I've spent an awful lot of my recent time working as a frontline clinician on the intensive care units in Manchester. COVID threw a sharp focus onto the way we use PPE. A lot of it is brought in from other sectors. We're using it in ways that it's not designed to be used for, typically for longer periods than it's designed to be used for, and in environments that it's not designed to be used for. The face coverings are quite restrictive. They're necessarily tight-fitting, which makes it quite oppressive to wear. They can damage your skin of your face. It's very difficult to communicate with our colleagues. It's also really difficult to communicate with patients. And we're having very difficult conversations sometimes with patients about their care, sometimes about end-of-life decisions. And it's really difficult to have those conversations in an empathetic way if someone can't really hear you.
Hi Pete, my name's Abs. I'm one of the doctors here. How are you feeling?
I was approached by Designing Science and the University of Manchester wanting to know, was there anything they could do to help us working on the front line against this COVID pandemic? And my response was, we need better PPE. The pandemic gave us lots of additional problems, particularly working in isolation and a lot of Zoom meetings as a result. Let's meet the team.
I'm Patrick Hall. I trained as a mechanical engineer, but I tend to work as a product designer these days. And on this particular project, I guess I've had the role as project manager, trying to solve problems, helping us to interact with Brendan and suppliers and other people who can contribute to the project. A lot of articles in the news about people developing ventilators and trying other ways to help. So I wanted to see whether we could find a suitable project which we could really contribute to. So Designing Science, we're a really small company of independent designers and engineers. We tend to focus on the medical technology market, generally new kinds of medical devices, kind of things being invented by doctors and by university academics, generally doing things differently and involving a lot of technical risk and finding unusual solutions to difficult problems.
My name's Dr. Glenn Cooper. I'm a senior lecturer at the Department of Mechanical Aerospace and Civil Engineering. My main research area is to do with bioengineering, and that's more specifically to do with medical device development and really using engineering design to solve medical problems.
COVID-19 is an airborne virus, so to work safely in environments where it is present, healthcare workers need a physical barrier between them and their patients, a way to filter the air to make it safe, and all this needs to be comfortable and functional for them to perform their medical and caring duties. Employing a user-centred design approach, a team of medical doctors from Wythenshawe Hospital, product designers from Designing Science, and engineers from the University of Manchester worked together to create a personal air purifying respirator, the Bubble Papa, creating a protective barrier between the healthcare worker and the patient, filtering the air to create a virus-free and comfortable product to enable a safe working environment, minimizing electronics and simplifying the design to reduce cost and increase the availability of the product.
My name's Andrew Forbes. I trained as an industrial designer, and I worked quite a lot in the automotive field. And A large proportion of my career has been about shifting air one way or another. When I was in automotive, my main area of work was in the air conditioning systems. So it's bringing air into the car, keeping the passengers warm or cold, depending upon time of year, weather requirements, and then making sure you could duct enough hot air at the windscreen to defrost it on a cold morning, etc., all that sort of thing. So my involvement in the project has been about getting the air through the filter and into the hood, so that the user is kept ventilated, so it protects the user from anything that's airborne.
I'm Andy Spragg. I'm also trained as an industrial designer. To start with, all the shops are shut. It's really hard to get sort of materials. My main thing is sort of looking at concepts and different ways of doing things. But in order to make sort of early proof of principles, you need to sort of start making models. And as soon as you get physical things in your hand, it's easier to work out what's going on. So you may see some photos of me working on the kitchen table, even cutting up things. I needed some foam to try and make this early yoke that we put around a head. So that was made out of a bit of sort of surfboard. Then they were using things like bin liners, plastic bags, anything to try and start proving the concept. At the beginning, we tried to figure a way of measuring the flow. And there's electronic ways of doing that, but because of the supplies and everyone was buying up electronic flow sensors, we couldn't get hold of them. So we tried to make it as cheap as possible and look at mechanical solutions. We sort of playing around with a cheap mechanical prototype, trying to see how we could measure flow using a simple spring and a sort of rotor.
Most PAPR units are over-engineered for what we need in the healthcare sector. We've designed and engineered the bubble PAPR to be as simple as possible. It's got no electronics, it's got no active moving parts other than a motor. It's as simple as we can possibly make it. It's easily cleanable. The hood is one piece of plastic that can be easily disposed and even recycled. We've tested it in the lab and we know it performs its primary function, which is to protect staff against inhalation of airborne viruses. We've also now tested it in the simulated clinical environments that we would use this device in, and that includes high-risk situations such as intubation, managing cardiac arrests, but also looking after patients more generally and communicating with staff.
The cardiac arrest, can we get the crash trolley, please?
So the reaction from staff has been overwhelmingly positive. When they saw something that wasn't restrictive on their face, that allowed them to communicate to their colleagues, that was pleasant to wear, allowed them to interact with their patients, they were made up. So we need this product now, and that's what's driving us to move things so rapidly.
Hi, is it Pete?
Yeah, hi.
My name's Abs, I'm one of the doctors.
Hi, nice to meet you.
We also can see what's happening around the world, and there's a finite supply of PPE. And so if we can bring a useful addition to the PPE market, we're sure that this can help. We evaluated Bubble PAPR in a lot of detail, and we wanted to ask these key questions. Can I speak clearly to my colleagues? Can I be heard clearly to my colleagues, especially if they're wearing FFP3 masks? Can I speak clearly to my patients? And can I be heard by my patients? Because tracheostomy patients, in common with many patients in the ICU, have real difficulty understanding and communicating us, particularly when we're wearing FFP3 masks and all the PPE that the staff had to wear, and particularly when they have trouble trying to communicate themselves. And they're often very reliant on our facial expressions, and that communicates a lot. So having a clear system we thought would be very helpful. What we found was that there was a very clear difference between the usual PPE that staff were having to wear, which is typically an FFP3 mask, and then headwear and goggles, and sometimes a welding type visor, and the Bubble PAPR. So the Bubble PAPR, despite being a little bit noisy, actually made communication a lot better, both between staff and between staff and their patients. So we think this is going to be a very useful addition to the PPE that we have to keep staff safe, but also help to communicate with patients. Thank you for listening.